We're talking about simplifying radicals, and we want to be able to simplify radicals in different forms. So here we have the product property. So if we have a number that we can break down into two products, then we can take the square root of the individual product. We have the same thing with the quotient property. If we have a fraction, we can take the radical and we can separate it just the numerator and just the denominator, and then we can simplify those individually rather than trying to simplify the entire fraction. And if we have a negative radicand, so that means the a, or the radicand means the value that's underneath the radical is negative, we can separate that into the square root of a times the square root of -1. And the way that we can rewrite the square root of -1 is we can write it with an I in front. It stands for imaginary because we really can't take the square root of a negative, but that is a way that we can establish that. So here we have some examples. We have example 1 here. Simplify the following expression. We have the square root of 18. Well, we know we can write the square root of 18 as two products. So we can write it as the square root of 9 multiplied by the square root of 2. We don't know what the square root of 2 is, but we do know the square root of 9. So then we can write this as 3 times the square root of 2, and then that is in the simplest form. Then we can look over at example 2, and that is in the quotient form, and we can write that as, rather than try to simplify this all together, we can rewrite this as the square root of 2 over the square root of 25. And in that case, we know that the square root of 25 is 5. So then we can leave that as the square root of 2 over 5. Then we can take a look at example 3 and 4. Here in example 3, we have the negative for the radicand. So we can separate this and we can write this as the square root of 25 multiplied by the square root of -1. In that case, we know that the square root of 25 is 5, and we can rewrite the square root of -1 as I. And then that is in its simplest form. Now we look at example 4, and whenever we have the square root, we know that we have an understood 2 here. So we understand that there's a 2 right there, and we have to simplify that. So we need to be, in order to take something out of the radical, we need to find 2 of that thing. So I'm going to rewrite what's underneath the radical here. So 36, I know I can write this as the square root of 6 times 6, and then I have 2 x's, 1, 2, and 3 y's, 1, 2, 3. So whatever is in the radical, whatever's under the radical, I need to have 2 of them. So here I have 2 6's, so that can come out. And then it comes out as just 1. Here we have 2 x's, so that's going to come out as just 1. And here we have 2 y's, so that's going to come out as just 1 y. There's still a y left that I can't pair with it, so that has to stay under the radical. So then what we're left with is the 6 came out, 1 x came out, 1 y came out, but still underneath the radical is that 1 y that's left under there. And then our last 2 examples here, we have example 5 and example 6. Same type of deal. We have to be able to find 2, because that's understood 2. We have to find 2 of those things in order to take it out. So let's see what we can rewrite 28 as. We can rewrite 28. Well, first let's keep the 6 there. And then we can rewrite the 28 as 2 times 2, which is 4, times 7, That gets us to 28. And then how many x's do we have? We have 4 x's and 5 y's. And so we have 2 2's. Those can come out. There's nothing to pair with the 7, so the 7's got to stay under. We have 2 x's. We have 2 more x's. We have 2 y's. We have 2 more y's. And that y has to stay under. So we can rewrite what we have here. So we have the 6 that's already there. We have to keep that. We can bring 1 2 out, so it's going to be multiplied by 2. We can bring another x out. We can bring an x out. We can bring 1 y out, another y, and that's all the pairs we have. A 2, an x, a y, and a y. Now what's still remaining under the radical? We still have a 7, and we still have a y. And so the last thing we have to do is just kind of multiply these together. And so we get 6 times 2 is 12. Then we get x squared, y squared, and then left under the radical we have 7y. And then that is in simplest form. And then we have our last example here. When we have radicals like this, we can multiply them together under the radical. So what we can do is we can multiply the 3 times the 4, and we can multiply the square root of 5 times the square root of 40. So 3 times 4, and then under the same radical, what I want to do is I want to say times the square root of 5 times 40. And then we want to think about what could we break 40 down that might help us match this 5 here. So then we can get 3 times 4, and then we still have the 5. Two numbers that multiply together to 40 are 5 and 8. So that's working. Now we have this pair right here. So we can bring that out. And then we still have the 8. The 8 can still be broken down. So now we have 3 times 4 times 5, because we brought that 5 out. And then what can we break 8 down to? We can break 8 down to 2 times 2 times 2. So we have 2 2's that we can bring out, but there's nothing to pair with that last 2, so that has to stay in. And then we're going to be left with 3 times 4 times 5 times 2 multiplied by the square root of 2. And what is that going to be equal to? 4 times 5 is 20, times 3 is 60, times 2 is 120, and then square root of 2. And then that is in the simplest form right there.